Hi students, welcome to ACE Online. I am Lankeshwar Sir, General Science and Science and Technology faculty. So in today's class, in today's section, we are going to discuss about some of the important questions which concerns to general science. So in RRB CBT-II examination, mostly we will get 15 questions from general science. So 15 questions from general science means physics, the concerned subjects are physics, next chemistry, okay, chemistry. You should follow 8th to 10th NCERT textbooks, right? NCERT textbooks. So that too basic levels only. Basic levels only. That is enough for mostly for this RRB JE examination, RRB JE CBT-II examination. Here we'll show some of the important questions, especially for this general science. So here it is, the first one. What is the more common name for solid carbon dioxide? Solid carbon dioxide. So solid carbon dioxide. Mostly in some occasion, okay, some functions you can observe this type of derivatives. Now this is called as white smoke. Okay, so sorry, not white smoke. So we are getting some kind of white, a foggy related smoke related derivatives. So how can we get this type of derivatives? First we have to consider hot water. So in that we should pour some amount of dry ice. Okay, so dry ice means nothing but solid CO2. Solid CO2, solid form of CO2 is generally called as dry ice. Okay. So its boiling point is minus 78.5 degrees centigrade. Of course, it can be used as a one of the refrigerating agent and coolant also. Okay, so coolant and refrigerating agent also. Next, some of the biological species or biological organisms. So biological organisms. Okay, so organisms are mostly preserved, okay, so mostly stored in this dry ice. Best example, animal sperm. So animal sperm can be stored in dry ice only. So dry ice, at the same time liquid nitrogen also, liquid nitrogen. So this liquid nitrogen boiling point is also around 196 degrees centigrade. Okay, so here it maintains a very low temperature. So the subject to study about low temperature region materials is nothing but cryogenic. Okay, so cryogenic, right? So what about potash? Potash means nothing but that is one of the element, right? So potassium related derivatives. Next, Epsom, it is a salt. Quicksilver, of course, mercury is called as quicksilver. Quicksilver. So that's why you have to remember this this terminology. It's very important. Quicksilver. So mercury, the percentage of silver in quicksilver, 0, because in mercury we are not having any silver related derivatives. So when mercury reacts with any metal, so mostly we can get the concerned alloy. What is the name of mercuric alloy? Amalgam. Okay, so the name of the mercuric alloy is called as amalgam. So mercury can form amalgam with any metal except two metallic derivatives. One is iron and the second one is platinum. So from this, okay, so from these two metals we are not expecting any amalgam related alloy derivatives, right? Okay, right. Next question. Here it is, the second one. The principle involved in the motion of rocket. Actually, the working principle of rocket is, so this is a PSLV rocket. It has 4 stages. The working principle of the rocket is law of conservation of moment. Law of conservation of moment means, actually it is derived from Newton's third law. Okay, so Newton's third law. It is derived from Newton's third law. If you consider two objects, two vehicles like this. So this is one vehicle. It is a moving object, right? Its velocity m1 and velocity m1, mass is m1. So by the product of mass and velocity, what we get? Momentum. Next, here it is the second object. So here this one is also exhibiting some mass. Next, velocity v2. So this is the direction of this object. So here we are getting momentum p2. So before collision, so the momentum is p1 plus p2. After collision, the momentum is p. So here there is, okay, so when these two objects are collide with each other, there is no formation of no gain or no loss of momentum, right? So this is called as law of conservation of moment, law of conservation of moment. So before collision and after collision, momentum is same. So this is considered as law of conservation of momentum. Of course, it is derived from Newton's third law. So here the correct answer is option B only, law of conservation of momentum, law of conservation of momentum. What about missiles? What about missiles? Mostly in missiles, guys, we have to use directly Newton's third law. Okay, so Newton's third law. Newton's third law. For every action, there is equal and opposite reaction. Action, next reaction. Okay, action and reaction. Both are completely reverse. Suppose towards downward reaction, let's imagine here it is the action. Towards upward reaction is there. Towards upward reaction is there. These two are same forces. Same forces. So here the correct one is option B only. Next, the purpose of using an electric fuse in an electric circuit is. So in electric circuit, guys, we are using mostly electric fuse. Suppose if you are getting excess amount of excess electrical current, then so excess electrical current in a domestic point of view, then what will happen? So most of the electronic gadgets are getting to be collapsed. That's why to overcome this one, we have to use electrical fuse wire. So because of that, here the correct answer is option D only. Option D only. So what is HLI is used to make ideal fuse wire. Ideal fuse wire. Ideal fuse wire. Actually, ideal fuse wire is made up with solder. Solder. This is one of the alloy, and it has lead plus tin. Okay, so lead, and this is tin. This is tin. So what is the specifications of ideal fuse wire? So why should we use a fuse, especially in the domestic point of view, not only domestic point of view? Why are you using fuse related derivatives? The reason is to protect from excess electrical circuit or electrical current. Suppose if you are getting excess current, then what will happen? So this is a solid material. Fuse is a solid material. So when we get the excess current, here electrical energy can be converted into heat energy. Okay, heat energy. This phenomenon is called as resistance. This phenomenon is considered as resistance. Suppose if the resistance is high, then this wire can easily get into be heated. So that's why, guys, here this one is having high resistance. Okay, if the resistance is high, then only this material easily cut into two different or three different type of species, right? So for that one, guys, here we have to consider a ideal fuse wire. What is the specification of ideal fuse wire? It has high resistance. Suppose if it has high resistance, then what is the advantage? Solid can easily, so mostly here it can easily be heated. Next, after heating of this material, then what will happen? So solid can be converted into, solid can be converted into liquid, right? Means here the wire can be broken. So broken means at that region the solid material is getting to be melted. Okay, so what is the name of the phenomenon when solid converts to liquid? What we call melting. Okay, so melting. The name of the phenomenon is called as melting. So it has low melting point. Suppose if the melting point is low, so just a matter of small amount of temperatures, small amount of heat variations, this wire can be broken. So that's why ideal fuse wire is having high resistance and low melting point. So it can be made up with lead plus tin. This is called as solder. So this is one of the alloy. And here the correct answer is option D only. Next one, when we cut onions, the synthesize, so the synthase enzyme convert the amino acid sulfoxide of the onion into which acid? Okay, so when we cut the onions, we are getting one of the acid. What was that? Okay, so what was that? Here, nitric acid, citric acid, sulfonic acid, sulfuric acid. Actually, here we are getting mostly option C, sulfonic acid. The reason is In onions, guys, we have excess amount of sulfur related enzymes, excess amount of sulfur related enzymes. Okay, so here you can observe that. So amino acids of sulfoxide is converted into sulfonic acid. Okay, so converted into sulfonic acid. Actually, its concentration would be somewhat high. So when we have this type of sulfonic acid derivatives on the eyeball, then we are getting sensation. Okay, we are getting signal from brain, right? So here the concentration is high, so that's why we have to reduce the concentration. For that we are using some tears, right? So we can secrete some we have to secrete some tears, then only the concentration of the sulfonic acid can be reduced. Okay, so this is also one of the interesting point. You should remember that. Should remember this concept, right? So sulfonic acid. Next, calcium sulfate dihydrate is commonly known as, calcium derivative is commonly known as, so CaSO4 2H2O. Okay, so calcium sulfate dihydrate. So this is dihydrate, na? It is called as gypsum. It is called as gypsum. So that's why here the option is option D only. Suppose, guys, when 120 degrees centigrade, if you consider gypsum, it can be converted into POP, nothing but plaster of Paris. Okay, so plaster of Paris. So CaSO4 half H2O. CaSO4 half H2O. This is called as plaster of Paris. Or it is also treated as CaSO4 2CaSO4. For these two molecules, we should consider one water molecule. Now, what is the name of this derivative? Plaster of Paris. What is the chemical name? So hemihydrated. Okay, hemihydrated calcium sulfate. Hemihydrated calcium sulfate. So how to get this material? By the heating of gypsum derivative, by the heating of gypsum, na? So what is the name of this process? This is called as dehydration. So dehydration means gypsum can be converted into, okay, so gypsum. Dehydration means loss of water. So by the loss of water, or by the removal of water derivatives from the gypsum, what we get? Plaster of Paris, na? Suppose if we observe any loss of water related derivatives from the product, the name of the process we can consider like dehydration. Okay, right? So here gypsum is added in cement, right? Around 2 to 2.5% gypsum is added, especially in cement. The reason is to increase the setting time. So we have to add. So we have to add mostly calcium sulfate, nothing but gypsum related derivatives, na? So calcium sulfate dihydrate. You should also remember the chemical name of gypsum, calcium sulfate dihydrate. What about glass? Glass is a mixture, right? Glass is a mixture and it has silicate derivatives, na? Silicates. Okay, so SiO2, silica. Next, calcium carbonate related derivatives are also there. Calcium carbonate derivatives and aluminum oxide. Okay, so aluminum oxide can also be observed, na? So what about asbestos? In asbestos, guys, we have some of the iron related constituents also. Next, what about limestone? Okay, so limestone means nothing but calcium carbonate. So this is called as limestone or marble stone, abrasive in toothpaste, nothing but this chemical limestone, na? Gypsum, we already discussed about that. So here it is. This is the gypsum, right? This is the gypsum. By the addition of gypsum, the setting nature of cement has been increased. Next, methane. Methane is a colorless, odorless, non-toxic but flammable gas. So what is its common name? Natural gas only. In natural gas, what we have? Methane related derivatives, na? What about laughing gas? Nitrous oxide, N2O. So nitrous oxide. So this is used as an anesthesia or anesthetic anesthesia in the root canal operation, na? Root canal operations, mostly we are using nitrous oxide is an anesthetic drug. So this is also one of the most commonly used anesthetic drug, just like chloroform. Just like chloroform. These two are the commonly used anesthetic drugs, nitrous oxide and chloroform. Next, blue vitriol. Blue vitriol means copper sulfate. Okay, so copper sulfate, copper sulfate. Okay, so copper sulfate, CuSO4, 5H2O, CuSO4 5H2O. This is called as blue vitriol, nothing but copper sulfate. Copper sulfate. It is acts as insecticide. Okay, insecticide. Insecticide. Here, guys, you can observe that. Here, you can observe that. Okay, so insecticide mostly here you can observe that. Next, natural gas. Okay, so methane. Methane. What are the common names of methane? Where would you observe these methane derivatives? Mostly in natural gas. Next, CNG. Next one, LNG, liquid natural gas. Next, PNG, piped natural gas. Next one, gobar gas. Okay, so gobar gas, gobar gas. Next one, biogas. Okay, so biogas. Next one, CNG means compressed natural gas. What about LNG, liquid natural gas? So biogas. Next, polished rice. So polished rice, from polished rice also we are getting the same chemical. Next one, oil gas. Okay, oil gas. Next, marsh gas. Only from coal mines we can observe this marsh gas. Of course, it is a poisonous gas, right? So marsh gas. Next, coal gas. Okay, so coal gas. These are all considered as, okay, natural, biogas, CNG, LNG. Okay, so these are all considered as some of the common names of methane. Next one, heating gas. Okay, so heating gas means number of fuel derivatives, gases derivatives are used for that. So specifically we didn't have particular chemical constituents, particular chemical name, so that's why here it is not having any particular name. Next, which of the following can be used as a catalyst in hydrogenation reaction? Hydrogenation means nothing but addition of hydrogen. If you consider oil, or fat, okay, if you consider oil, mostly oil, how can we convert it into fat? Oil is having unsaturated hydrocarbons, unsaturated hydrocarbons means C double bond C. So when it is added with okay, so when we add hydrogen related gas in presence of either nickel or palladium or platinum, these are the catalyst. Okay, so that's why here they mentioned palladium. Option C is the only right answer. Option C is the right answer. So oil here can be converted into fat, nothing but dalda. Okay, so dalda or vanaspati. So vanaspati. So unsaturated hydrocarbons are converted into saturated hydrocarbons. Hydrocarbons means C double bond C derivatives are converted into C single bond C derivatives. So when did this type of phenomena possible? By the addition of hydrogen only. This is called as hydrogenation. So here the correct one is option C only. So where would we observe tungsten? Use it to make filament. What about iron? So iron is a catalyst in Haber process. Okay, so Haber's process. Okay, means nitrogen when reacts with hydrogen, guys, what we get? Ammonia, NH3. Okay, so ammonia. Here we have to consider 1:3 ratio of nitrogen and hydrogen. Finally, we can get ammonia. So in Haber process, which chemical can be mostly produced? Ammonia. This is the best nitrogen supplier. Around 83% of nitrogen it has. Compared with urea, in urea we have only Okay, so in urea we have only 46% of nitrogen derivatives, but here we have excess amount, approximately 83%. 83%. Here the catalyst is iron. Okay, in Haber process, so to increase the rate of reaction, we have to consider iron as a catalyst. Next one, which of the following is not iron ore? Not iron ore. Here they mention ore means one of the raw material to extract the metal from industry, na? Okay, to extract the concerned metal, especially in industries. Okay, so here you can observe siderite. Siderite means iron carbonate. Iron carbonate. Hematite means Fe2O3. Fe2O3. Next, cuprite means Cu2O. Next, magnetite means Fe3O4. Fe3O4. Okay, so here they mention about not iron ore, na? So that's why we should consider option C only. Okay, so we have to consider option C only. C is the right correct one. Siderite. In siderite, guys, we have around 42.5%. 42.5% of 48.2%. 48.2% of iron. Na? What about hematite? 69.9% of iron. What about magnetite? 72.4% of iron. 72.4% of iron. Okay, you should also remember these concepts, right? Next one, which of the following is also known as Epsom salt? Actually, Epsom salt is nothing but magnesium sulfate, MgSO4. MgSO4 7H2O. This is called as Epsom salt. So MgSO4 7H2O. How many water molecules it has? 7 water molecules. What about ferrous sulfate? So ferrous sulfate means like this, na? FeSO4 7H2O. Okay, FeSO4 7H2O. Here in this ferrous sulfate, it is also, sorry, in this ferrous sulfate we have 7 water molecules. It is called as green vitriol. Okay, so green vitriol. So what about calcium sulfate? CaSO4. If it is having 2 water molecules, what we call nothing but gypsum. If it is having off water molecule, that is called as plaster of Paris. Next, sodium sulfate, Na2SO4. Okay, sodium sulfate, Na2SO4. So for this purpose, guys, to clean the food related constituents, if we are facing any fungal related infections, mostly to clean that one, we have to consider magnesium sulfate derivatives, na? Next, if you are facing any constipation issues, then also we have to consider Epsom salt. So Epsom salt is used for purgative for adults, na? This can be used as purgative for adults. Purgative for adults means if you are facing any constipation problem, to overcome that we should consume magnesium sulfate, nothing but Epsom salt, by the addition of some water and lemon juice. So then okay, so only then you have to add magnesium sulfate. Next one, the mirror used by a dentist is. A mirror used by dentist is. So plane mirror, concave mirror, convex mirror, cylindrical mirror. So plane mirror. So here the correct answer is dentist. Dentist used mirror is generally considered as concave mirror. Okay, so concave mirror. Okay, so here it increases the size of the image. That's why we have to consider a concave mirror, na? So if you consider mirror, guys, so only one side we can observe the image. On the second, okay, below the mirror, silver coating mostly we observe, na? Silver coating means silver paint, mostly we can observe on the mirror. So silver paint means it has aluminum oxide derivatives. Okay, right. Next, so the working principle of mirror is reflection only. The working principle of mirror is reflection only. Next, mirror can be, okay, so actually in mirror, if you consider mirror, here it is also classified into 2 types. One is plane mirror. Okay, so plane mirror, and the second one is spherical mirror. spherical mirror, spherical mirror. So there is a difference between mirror and lens. So present I am using lens, right? So this is a concave lens, concave lens. So concave lens means I am not able to observe far objects. Okay, so this is called as myopia. Myopia means near objects are visible, far objects are not visible. That's why this lens optical power is in minus 2, minus 1.5, minus 1, like that. Okay, if it is minus, so what kind of lens mostly we need? Concave lens. Okay, minus means concave lens. Concave for which vision defects we are using concave lens? Myopia, myopia. Suppose if near objects are not visible, then you have to consider convex lens, convex lens. Okay, even in eyeball also we have convex lens, right? Yes. So what about the optical power, positive or negative? Positive. If you are using convex lens, then the concerned person is facing hypermetropia issue, then its value would be, its optical power would be positive only. So spherical mirrors, again it can be classified into two types. One is concave. Okay, so concave mirror. So next second one is convex mirror. Okay, so convex mirror. So in plane, suppose if you are using plane mirror, guys, to get the complete image, so we have to consider half of the image of this object. Means to get the complete image of the object, you should consider half of the image of this object size. You have to consider the mirror. Okay, the mirror height should be half of the height of the concerned object. Suppose here my height is, let's consider, not consider, my height is, okay, so 160, okay, so 160, just for sake of our convenience, 160. So then how much size of mirror we need? I need to get my complete image. So 80 centimeters, 80. So means, yes, 80. 160 by 2 means nothing but 80, right? So we have to consider 80 only. So next, here in plane mirror, left can be converted into right, okay, so right converts to left. That kind of inversion takes place. So this is A and this is B, and here it is B and here it is A. So inversion takes place by using plane mirror. That is one of the defects of plane mirror. Next, how many images we get? For that we have to use this formula. So number of images n is equal to 360 by theta minus 1. Theta minus 1. Suppose if you consider two mirrors, here the angle is 180, then 360 by 180 minus 1, one image. We are getting one image. Suppose if the if we consider two mirrors like this, okay, merged with one another like this, and here the angle is, just for sake of our convenience, we consider 90 degrees. Then how many images we get? 360 by 90 minus 1, 3 images, So you should also remember the formula. Next, concave mirror. So by using concave mirror, we can increase the size of the image. Next, what about convex mirror? So by using this mirror, we can reduce the size of the image. What about lens? Okay, so convex lens we have, convex lens we have. Next, concave lens we have, So this convex lens is used for, so its optical power is, okay, optical power indicates with P. So this is called as power of lens. Power of lens P is equal to 1 by F. So here F means focal length. The focal length should always consider in meters only. Suppose if you are getting P is positive, then so P is positive, okay, so then that is positive, convex. Next, P is negative, then, okay, so here the value is negative, then that lens is nothing but concave lens. So this convex lens is called as converging lens. Okay, so converging lens. Why? Because by using this lens, almost all the rays are merged at one particular point. This is considered as converging phenomena. Suppose from one point, if light rays are being deflected like this, then this is called as diverging. So this is considered as diverging. Okay, so diverging lens. But here concave mirror is treated as converging mirror. So convex mirror is treated as diverging mirror. Diverging mirror. So by using convex lens, we can reduce. Okay. So if you observe the myopia cases, mostly guys, here it is the image. This is the retina. Okay. So this is the retina. So first this image, this object image should be placed on this retina, and then only we can get the vision sensation. But myopia patients, okay, if you observe myopia, so myopia patients, their image is focused at here only, means focal length mostly decreases. So before the retina image has been placed, that's why we have to increase the focal length. For that we should consider concave lens. What about convex lens? Convex lens, here the image is placed behind the retina, means focal length has been increased. That's why to reduce that one, we should consider convex lens. So that is the difference between these two things. So you are getting at least one question from this concept. That's why you should majorly focus on this area. So side mirror is concave mirror. Why? Because it increases the size of the derivatives. Okay. Next, what about rear view mirror? Concave side mirror. Side mirror is convex mirror, not concave. Why? Because if the size of the object is even large, if you are using convex mirror, you can reduce that. That's why side mirror is always convex only. What about rear view mirror? Rear view mirror is also convex mirror. Convex mirror, it reduces the size. Next one, which of the following is used as substitute for mercury in the thermometers? Generally we are using mercury, at the same time alcohol derivatives, alcohol, okay, alcohol, next mercury. But here they raised about what is the alternative for this mercury, especially in thermometer. So selenium, so gallinston, bromine, arsenic. Arsenic is a poisonous. So next bromine, this type of liquid derivatives are not be used. So majorly we are using this alloy. So gallinston. Okay, so gallinston is the correct answer here. So gallinston is a alloy, and it has, okay, eutectic alloy, and it has gallium and indium and some of the tin derivatives. Okay, so tin derivatives, and it can be melted at minus 19 degrees centigrade. Minus 19 degrees centigrade. Of course, it is exist in liquid state, So gallium, indium. So gallium. Next indium. So boron, aluminum, gallium, indium. Okay, so these two elements along with tin. So carbon, silicon, germanium, next tin. Here we have tin. So these three elements are used to make mostly this gallinston. Okay, so here the correct answer is option B only, gallinston. Next one. Light travel fastest through which of the following? Okay, light travel fastest to which of the following? What is the light velocity? Approximately 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. Okay, so next exact value 2.9 into 10 power 8 meter per second. So who initiated this value? Foucault. Okay, so Foucault. So the velocity of light is maximum in vacuum. Means if mu value, okay, so mu value increases, then velocity of sound, velocity, so this is inversely proportional to velocity of light. So mu means nothing but refractive index. Refractive index. If refractive index is high, then velocity of light mostly decreases. Velocity of light decreases. Here if you consider diamond, its a refractive index value 2.42, air 1.005. It is not having any units. Next water 1.33, glass 1.5. So that's why here the fastest one is, okay, mostly option B only. Option B only. If you consider the order, so air followed by water, next glass, next diamond. Okay, so diamond. So velocity of light mostly reduces, especially in the diamonds. Now the reason is here refractive index of the diamond is somewhat high. Okay, which material is having highest refractive index? So mostly diamond. Actually, diamond is not a material. Generally, we consider like that. Diamond is an element. Diamond is considered as an element. Okay, right. So here you can observe that based on the refractive index values, we can conclude the velocity of sound. Sorry, velocity of light. Velocity of light. Next, a common fluorescent tube. A common fluorescent tube contains. So fluorescent tube contains mercuric vapors and argon gases. That's why here the correct one is option D only. Option D only. Okay, so here you can observe that. So in these filaments, guys, okay, not filaments, mostly in CFL bulbs, we can observe argon, next nitrogen, next some of the mercuric vapors related constituents are also be there. No? Next, with reference to noise pollution, what is the threshold limit for sensation of pain in the ear? So what is the sensation? Okay. So with reference to the noise pollution. Okay. So first of all, noise pollution means if the intensity of sound. Okay. So intensity of sound is more than 80 decibels. Then only it is considered as noise pollution. Noise pollution. Okay. So intensity of sound depends upon the amplitude. Okay, intensity of sound depends upon the amplitude. So amplitude means, suppose if you consider a wave like this, so this is crest and this is trough. So the maximum displacement from the mean position is considered as mostly amplitude. So this is amplitude, and this one is also considered as amplitude. So here with reference to the noise pollution, what is the threshold limit for sensation of pain in the ear? Pain in the ear. Of course, our ear can hold up to 120 decibels. Up to 120 decibels. 120 decibels. So that's why here, guys, 80 decibels, 120 decibels, both are there, na? With reference to noise pollution. Noise pollution means more than 80 decibels. Okay, so 120 decibels is the correct answer. The reason is, this is the, okay, so this is the threshold limit for sensation of pain in the ear, right? So pain in the ear. Okay, right. So next, whose voice is having highest, which one, if you consider male and female voice, so here intensity is maximum for whom? Male voice. High intensity or high amplitude. Male voice is having high amplitude and low pitch. Pitch always depends upon frequency only. What about female voice? Low amplitude and high pitch. Low amplitude and high pitch. Na? So amplitude means like this. What about pitch? Nothing but frequency, number of waves per second. If you consider female voice, so their voice is having, okay, so within 1 second they emit maximum number of waves, na, compared with male. So that's why you have to remember this terminology. Okay, so remember this terminology. So Noise Pollution Act is also there. According to Noise Pollution Act, noise pollution means more than 80 decibels only. More than 80 decibels. 80 decibels only. But our ear can hold or can sustain up to 120 decibels. Suppose if it is crossed than that, then our eardrum can be broken. So that is the interesting concept here. right. So which of the following is most viscous? Most viscous. If you consider liquids, not only liquids, fluids. Okay. If you consider fluids, it exhibit cohesive and adhesive forces, na. So it has cohesive and adhesive forces, na. So viscous forces means the resistance of flowness of liquids. Means suppose when we poured water on the surface, so those layers are easily displaced from the existed one, right? When we poured here, within small span of time, water is moving like this. What about honey? If you poured the honey, so almost those layers are not easy to displace, na. So this is the honey related derivatives. Let's consider like this. Here you can observe the shape is in this orientation, na. So this is the first layer molecules. Let's imagine this is the second layer molecules. So these second layer molecules always drag the, okay, always pulls towards the backward of this motion. Okay, so it does not interested to moves towards forward. So that is nothing but, okay, one force, it restricts the movement of the liquids, na. So that force is nothing but viscous force. Which one is having highest viscosity? Mostly grease. Second one honey only. Okay, honey only. So that's why option D is the right answer here. Okay, so what are the units of viscous forces? Poise. Poise is considered as units of viscous forces, na. Next, mirage. Mirage is the best example for which of the following phenomena? So mostly on hot day you can, okay, so hot days you can observe in these black road skies some of the, okay, sometimes it get into be wet, na. The reason is here it is the observer. Near to observer it has denser medium, nothing but cold air. Okay, so here if you are getting a white smoke or looking like wet, here hot air mostly be there. So this is rarer medium, this is denser and this is rarer. When light passed from denser to rarer, so almost all the rays are bounced back in the denser medium only. So the name of the phenomena is called as total internal reflection. If you consider optical fibers, okay, so optical fibers, next these mirages, next looming phenomena, okay, almost all these are working on the principle of total internal reflection only. Why diamonds are exhibiting glittering phenomena? Why diamonds are glittered in nature? The reason is total internal reflection. Total internal reflection. Okay. Here you can observe that. So here you can observe, if you consider water, guys, its critical angle is 48 degrees. If you consider diamond, its critical angle is 24 degrees, approximately 24 degrees. Next, what is the source of electric energy in an artificial satellite? Okay, what is the source of electric energy in the artificial satellite? So if you consider artificial satellites, we are using solar panels. Mostly solar panels or nuclear batteries. Okay, nuclear batteries. So these nuclear batteries are also called as thermoelectric generators. Okay, so thermoelectric generators. Thermoelectric generators. Okay, right. So what is the importance of thermoelectric generators? So it converts heat energy into electrical energy. So for that, in these nuclear batteries we are using either uranium or plutonium derivatives. So here the correct one is mini nuclear reactor, mostly not possible as of now. We didn't have that much of technology, especially to operate artificial satellites. What about solar cells? Yes, we have. So this is one of the possibility now. Option B is the right answer only. Option B is the right answer. If you are using solar panels, guys, mostly we can get the DC current. Okay, so DC current can be converted into AC current by using what? By using which device? If you know the answer, please comment in the comment section, right? So next, optical instrument that is used by army personnel to see the enemies while hiding themselves. Mostly you can observe this type of instrumentation. So plane mirror, we have to consider two plane mirrors like this in this Z shape. Suppose here it is the object and here it is the observer. So by using these type of instrumentation, they can easily notice so who are exist on the high altitude regions na. So this kind of instrumentation we can observe in submarines, mostly in bunkers by armed forces, mostly army persons, right. So here the angle is 45 degrees. We can consider plane mirror, either plane mirror or what we call Nicol prism. Okay, so Nicol prism also, okay, right. So that is nothing but periscope. Okay, so periscope, here it is. So this kind of constraints you can observe, mostly this kind of derivatives you can observe na. So periscope. Electromagnetic radiation is used in radar means radio detection and ranging system. Radio detection and ranging system na, ranging system. Generally in radar systems, guys, we are using microwaves. Okay, so microwaves. Suppose if there is no this type of option, then you can consider radio waves. Okay, so radio waves. These two are used in communicational assets, na, communicational devices, na. But here they mention microwaves. So that's why option B is the right answer only. So microwaves. By using radar, we can detect any kind of object, even in the atmosphere or in the space. Next, on the land also. What about in water? What about in water bodies? We have to consider sonar. Sonar means sound navigation and ranging system. Sound navigation and ranging na. So sound navigation and ranging. So in this, what we used? Ultrasounds. Okay, so ultrasounds. We are using ultrasounds. Of course, these two are working on the principle of reflection. Okay, so reflection. So here the principle is, here radar and sonar depends upon the Doppler effect, right. So Doppler's effect. So based on the Doppler effect concept, we can use mostly radar and sonar related technologies. Okay, so this is the total conclusion about today's class. Okay, so this is the total conclusion about today's class, guys. I hope you are understanding the concepts. You have to focus on the 8th, 9th, 10th physics and chemistry related concepts, especially for this general science. Okay, so here some of the important concepts are in physics. Okay, in physics you should focus on light, sound, mechanics. Next, electricity. Okay, so light, sound, mechanics, electricity. So these are the high scoring concepts, right. Next, magnetism also. You have to prepare especially from physics these 5 concepts. What about chemistry? Reactions, types of reactions. Exothermic reaction, endothermic reaction, combination reactions, decomposition reactions. Next, displacement reactions, double displacement reactions, displacement. Okay, so displacement reactions means, suppose if you consider copper sulfate. So this copper element can be replaced by one of the element, right. So what was that? Okay, so what is the, okay, so here we are getting XSO4 plus copper. So which metal can be displaced this copper element? So for that we have to follow SRP values, standard reduction potential values. Means we have SRP table, standard reduction values table, right. So here we have hydrogen. So based on this hydrogen, elements are classified. Na? So here we have copper, silver, gold, next platinum, mercury. So platinum, mercury, these are less reactive. These less reactive elements are replaced by more reactive. Lithium, next potassium, sodium, iron, okay, iron, next cobalt, nickel. So almost all the metals. Rest of the elements are existed at here only. Only these 5 metals are existed below the hydrogen. These are less reactive. These are more reactive. These are reducing agents. These are oxidizing agent. Okay, oxidizing agent. So that's why here we have to consider either iron, okay, so cobalt, nickel, whatever it is, Next, these metals when reacts with acid, it does not produce hydrogen, but if you are using concerned acids, mostly it emits hydrogen related gases. Na? So that is also one of the interesting point here. Next, reactions, second one, acids, bases, bases and salts, acids, bases and salts. Next, organic, nothing but carbon chemistry. Okay, so carbon chemistry. In carbon chemistry, methane, ethane, propane, butane, this type of things we have. Na? So what is the difference between methane and ethane? Methane formula CH4, ethane formula CH3. What about butane? So 4 carbons it has. Na? 4 carbons it has. So what is the difference? How many carbon particles are differenced here? Okay, so how many carbon particles are differenced here? 2 carbon particles. So if the difference is only CH2, that is called as homologous series. Next, some of the functional groups. In carbon chemistry, we have some of the functional group, aldehyde, ketones. So it just observed what is meant by aldehyde. Suppose if the functional group is like this, this is called as aldehyde. Okay, so you have to observe almost all these things. Next, water and its constituents. Next one, metallurgy means we have different types of alloys. Na? How to get the steel, okay, what kind of elements it has. Next, stainless steel. Next, bronze. Okay, so bronze. So next, classification of elements. Okay, so classification of elements. Next, periodic table. Okay, so periodic table, so atomic structure. So these are all some of the basic concept. So you should focus on these areas. Okay, definitely you can get the good score, so there is no doubt about it. If you observe the CBT-I, in the same orientation, guys, we can get this we can get the level of question. Okay, level of question would be very less, right? So sometimes they raised some of the mistakes in that. Okay, some mistakes are also possible. Na? That's why after completing of your examination, you should check the key. Okay, you should check the key. If you have any doubt, so please contact us. Okay, so we will also raise the key related objections. Okay, so by some of the questions in previous classes also, not previous class, in previous examination also we raised some of the objectional questions, na, right? So you should also focus about it. So before examination, after examination, you have to follow these instruction. You will definitely get a good score. I hope you are understanding the today's concept. I wish you all the best. Thank you.